Hello and welcome to Invalid Entry. My name is James Taylor and today we are looking at libraries, Python libraries. Because it is Advent, we're doing 24 libraries in 24 days. Yesterday I sort of broke the plug on doing system libraries, Python libraries, inbuilt libraries into Python. Libraries which I think are either underused or people just don't know about them. And this is one of those libraries called Turtle. It's actually inbuilt to Python. It comes with Python. It's in the Python standard library. It is called Turtle. And one of the reasons that I like it is because it is really good for teaching people how to program, especially those early things. One of the things that is very good when you're learning is if you have a very good response from something. So if you do something and you get that good instant response back, say, yes, that worked. If you're writing code, I think it can be years before you're able to write a large amount of code and then run it, knowing that the payoff at the end will be it all works. You want to write a little bit of code and see it works nice, especially when you're new to programming, to have that positive reinforcement, to understand what little change to your code may have big change in the output. So my eldest is currently learning to program, and she is using Turtle in that learning. I don't think it's very useful outside of learning Python, but I do think it's amazingly useful, especially for younger people, because it does give you these graphics outputs, a very graphical output, and it allows you to, let's see, there's an example here of a little program which we'll use in a moment. Because it's being used often by kids, you do want to take some leniencies on how they might use it. So they actually do from Turtle import everything, which is like, don't do that, please don't do that. But there's a reason why they want to do it, because they want to do color. They do red and yellow, and what this is the yellow. This is the line you're going to draw and the actual pen color. So the pen color is red, and then the fill will be yellow. If it joins up, it'll be yellow. So you can do begin, fill. But before we do that, let's just do some very simple things. So you can see down here, it is very simple. So it is just forward 10, left 90, forward 10, like that. Okay, so that's it. You then just run Python. I'm not in a virtual env over here. Let me just bring that onto the screen a little bit more. I'm not in a virtual env, but a bit bigger if you want. Python t1.py, and what happens is it closes very quickly. So I'm just going to go to done down here as well, because otherwise it exits. You can see here it's gone forward. It starts off pointing that way just because computer graphics, that generally is, or even in mathematics, that generally is the direction you start pointing things. We do in vectors, so that is the naught vector. It goes forward a little bit. It's to the nose of the arrow, so it actually is a bit more of a square than it looks like. And you can then teach people about arrays. So go for I in range 4, or loops. I can do a loop, forward 10, left 10, forward. I don't need the next forward there. So I'm going forward 10, turn left, forward 10, turn left. And then this should, at this point, make me a nice. I'm actually going to make that 100. And what's actually happening here is it actually draws it. It actually follows that out and draws me a nice square. I want to fill it. I can do begin fill like that. I can do end fill there. So I can start filling my thing in. If I get on there, it's actually still drawing it. See, then fills in the shape that I've got left behind. So straight away, we can start saying things. Well, can you draw a house? Can you draw a window? Can we do functions where you say, here's a function to draw a window. You can do pen up, pen down, those kind of things. But you begin to teach about how you can refactor code. So you can say, yes, I had one which was forward, turn, forward, turn, forward, turn, and then refactor that into I can do it as a loop. Repeat those things 4 times. You can begin to do, say I want a generic shape, so I can do sides equals 10, and I can do left equals 360 divide by sides. Okay, and I really hope this will make me I just clicked it in the wrong place as I ran it. But notice I got it wrong because I'm repeating 4 times, so I actually need to do it side in range sides. Sides. Bit lag on my keyboard there. And if I run that now, I'm sure I could probably take it to run on this screen, and then very quickly have a generic octagon shape. The main thing about this library is it's fun. It's fun to play with it. It's fun to make spirographs. It's fun to say, well, actually, I'm going to actually turn not there, but I'm going to turn 4 times or 6 times the number of that degree, and you end up getting the beginning of spirographs coming out. Obviously there I didn't know what that was going to make, and it's just repeating the lines because sometimes spirographs do that. So yeah, that is one. I could then say I'm actually going to do sides divide by 4, something like that. So I'm pentagram. Okay, so obviously my numbers here may be wrong. I may want to put this up to 36, 356. Wow, let's do a really large number. And it's getting the kids to play with those values and start seeing what they have, because the result is instantly gratifying. You see those results very quickly. They're fun to watch and go, yeah. And I also think some of these, I mean, I love spirographs. I love these kind of, anything like is computer generated like this on repeating things. Anything which is simple but then gives complex results, borders on the chaotic, borders on fractals, borders on those kinds of ideas and concepts. And it's going to loop soon because it's going to get back to its starting point, but it is actually probably going to do the full loop of 368. No, it hasn't. It's slightly off. So the fractal is slightly off. So you're actually going to get a more complicated spirograph. So if you haven't seen Turtle, or if you have children interested in programming, it's that bridge between like Scratch and proper programming, because you're beginning to import variables, you're beginning to use loops, you could do arrays, you can do function calls. It is a bit nasty because you're using kind of globals here. To do it without that, you would have to write, import Turtle to clean up your namespace a little bit, or your scope. You have to do color like that, and then you have to do turtle.forward. It's a bit weird in that you're not generating a Turtle class and then interacting. You are sort of interacting with the module directly, and the module remembers what it are. But as I say, it's for teaching kids, but I actually think there's a lot of value there in teaching anyone, because you get that instant thing back. So if you've done the Django tutorial, this is great. I don't think it's particularly great for teaching complex things or computer graphics, because you're doing vector-based movement rather than exact positioning. But you can do set x, set y, set y. You can do things like get the position. You can get the position back, which gives you a two-digit number, and you can then run absolute on it. So you begin to get the concept of complex numbers in there, which is quite cool. Pen up, pen downs, color controls, all the rest of it, fillings, clearing, show totals, all the rest of it. So you can do a lot of things with this. You can do clicks. You say go to here and draw another one. And yeah, it's a very, very cool little library. It's very well thought out because it is so simple to use. It does use degrees and not radians, so just be aware of that if you like to use radians. You can actually apparently change it to radians, but it will be used degrees by default. And that's it really. Like go have fun with this library, show your kids, give them over Christmas, let them make Christmas decorations, stars, snowflakes, those kind of things. Making fractals on this is super easy because they're generally like L-type fractals or snowflake patterns or trees. Those kinds of things are really easy to generate with this kind of iterative process or recursive process as well. That's all for today. If you're enjoying these, please hit like. There are more serious libraries in this series, like Requests and It's Dangerous and all those kinds of things. This is a little whimsical one, but I think people aren't necessarily aware it's there. I don't think I was aware of this library built into Python. You don't need to, if you've got Python, I believe it goes back all the way to Python 2.7. There you go, it's even in 2.7. It works on everything that you might be running on. It works on Windows, Linux, Macs, it works. So just get your kids down. Use a nice editor. I've seen people use all kinds of editor. Use a nice editor. I use Visual Studio Code. Got nice syntax highlighting, so you can teach people this is a hard-coded number or a magic number, in fact it's hard-coded, but this is a variable. When it shows up as blue, when you highlight it, it highlights where else it's used, so you can start teaching about good coding standard, good naming strategies. All those things which make you a better programmer, things that when you start learning programming, you have to learn a lot of little things across the breadth of programming, so you can start teaching that. As I say, nice light library. If you're enjoying these, have a look at what videos there are in this channel and maybe have a click, especially on this series for Advent, and maybe hit like and subscribe. Apparently asking you to that makes people do it, so please, and I will see you all in the next episode.